He is René Descartes, a French philosopher, mathematician, and scientist. His biggest contribution in mathematics is his discovery of the Cartesian coordinate system, which was named after his name, Cartesian coordinate system. A Cartesian coordinate system is made up of two perpendicular number lines that divides it into four regions called quadrant. These are the parts of the Cartesian coordinate system. As you can see, this line or the horizontal line is called the x-axis. The vertical number line is called the y-axis, and the four regions that was made are called quadrants. Quadrants was named in a counterclockwise direction, starting from this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. As you can observe, these are the positive integers. These are the positive integers, and these are the negative integers in our number lines. The point of intersection of the two axes or of the two number line is called the origin. And the origin has the coordinate of 0, 0. This is the example of coordinate. In this example, we have 4, negative 1. 4 is the value of x in our x-axis, and negative 1 is the value of our coordinates in our y-axis. So this is the point that represents 4, negative 1. All of the points that is located in the first quadrant has the sign positive, positive. All the points that is located in the quadrant 2 has the coordinates negative, positive. In our quadrant 3, the signs are negative, negative. And in our quadrant 4, the coordinates has the sign positive, negative. Our next activity is plotting a point. Let's say we have point A with the coordinates of 3, 2. By the way, then the first number in our coordinates, we have 3, 2, negative 3, negative 3, and 3. These are called the abscissa of our coordinates. And the second number in our coordinate is 2, 3, 2, negative 2, and 2. These are called the ordinate or the y values. Okay, let's go back to plotting a point. We will start from the origin, which is 0, and then count the number of units that is given here. The number is 3, so from 0, we will count 3 units, 1, 2, and 3. And then, from 3, we will count 2 units. Since this is positive, so we will go up 1, 2. Then, shade this portion. This portion now represents the point A with the coordinates of 3, negative 2. Letter B or point B has the coordinates of 2, 3. Again, from the origin, we will count 2 units to the right because this is positive, and then 3 units up because it is also positive. So from 0, we have 1, 2, and then 3 units up, 1, 2, 3, and then shade. This is now the point that represents B with coordinates of 2, 3. Letter C has the coordinates of negative 3, 2. So from the origin, we will count 3 units to the left because this is negative. So negative 1, negative 2, negative 3, and then 2 units up because the ordinate is 2, positive 2. So we have 1, 2. So this point represents point C with coordinates of negative 3, 2. Point D has the coordinates of negative 3, negative 2. So from the origin, we will count negative 3 or 3 units to the left. 1, 2, 3. And then negative 2. So 2 units down. 1, 2. Okay, so this point represents point D with the coordinates of negative 3, negative 2. Number 5 or point E has the coordinates of 3, negative 2. So from the origin, we will count 3 units to the right because it is positive. So 1, 2, 3. And then negative 2. So 2 units down. 1, 2. So this point represents point D, which is 3, negative 2. As you can observe, in plotting points, we will always start at the first numbers. So we're going to move from left or right before going up or going down. The next is to plot the point F with the coordinates of 3, 0. So again, from the origin, we will count 3 units to the right because it is positive. So 1, 2, 3, and 0 units to up or down. Okay, since 0, we can now shade this portion. Therefore, this is the point that represents F with coordinates of 3, 0. Okay, the next point is point G with coordinates of 0, 3. Okay, so from the origin, we will move 0 units. So we will not move from the origin. And we will move 3 units up because it is positive. So 1, 2, 3. Therefore, this is the point that represents point G with coordinates of 0, 3. The next point is point H with coordinates of 0, negative 3. So again, from the origin, we will move 0 units left or right. So it will remain here. And we will move 3 units down because it is negative 3. So 1, 2, 3. This is the point that represents H with coordinates of 0, negative 3. Our next point is point H with the coordinates of negative 3, 0. From the origin, we will count 3 units to the left because it is negative. So 1, 2, 3, and 0 units up or down. It will remain here. So we will shade that point, and that point represents point H with the coordinates of negative 3, 0. Our next topic is called equation. So an equation in the form of ax plus by plus c is called a linear equation in 2 variables where a, b, and c are constant and at least one of a and b are not 0. This is also referred to as the standard form of the linear equation. We will focus in this equation, ax plus by plus c, and this is an example of an equation. This is linear equation because the highest degree of the variable is 1. The exponent of x and y is 1, so that is linear equation. In 2 variables because there are 2 variables involved, which is x and y. And this is the standard form of the linear equation in 2 variables. The numbers with the variables in its term is written in the other side or in the left side of the equation, and the constant terms is located at the other side or at the right side of the equation. The symbol x and y in our example earlier, are variables that represent any number that will satisfy the equation. Okay, so x is the value that we can get in our horizontal number lines in our Cartesian plane, and y is any number from the vertical number lines in our coordinate system. The equation 2x plus 3y is equal to 32 is an example of a linear equation in two variables that is written in its standard form. It is linear because the exponent of x and y again is 1, and it is written in its standard form because the terms with variables is written on the left side, the constant is written in the right side. So this is two variables because of the variable x and y involved in that equation. Take note that that equation can only be true if we can find an ordered pair xy that will satisfy the equation. The equation earlier can be true or false depending on the values of x and the values of y. And we call that number x and y, or as you can see, this is an ordered pair or coordinates. These are the numbers or the solution to the linear equation in two variables. Example, we have to find two solutions to equation x plus y is equal to 3. What are the possible points? What are the possible coordinates? Or what are the possible ordered pairs that will make this equation true? What is the value of x that is added to the value of y to get the number 3? Okay, so in solving that, we're going to assign a certain number. As I've said a while ago, in our x values, we are free to get any number from our horizontal number line or x-axis, and this time we're going to pick x is equal to 1. In your solution, you can also use any number like 2, 3, 0, negative 1, negative 2, and so on. It's depending upon your choice of number. So let's choose x as 1. In this equation, x plus y is equal to 3. So instead of writing x, we will replace it by 1. So 1 plus y is equal to 3. And then solve for the value of y. Okay, by transposition, we have y is equal to 3 minus 1. Positive 1, if we're going to transpose it to the right side, it will become negative 1. So therefore, y is equal to 2. Therefore, the answer is 1, 2. Or these are the values that will make is the given equation true. Let's check. If we're going to substitute x by 1, that is 1, plus y, that is 2. So 1 plus 2, that is 3. Therefore, this equation will be true given the values of x as 1 and the values of y as 2. Okay, aside from that, we can also choose another number. Let's say, let us pick x as 1 or 4. We will substitute x by 4. So it will become 4 plus y is equal to 3. Therefore, y is equal to 3 minus 4, and that is equal to negative 1. Therefore, the values of x and y that will satisfy this equation or that will make this equation true is 4, negative 1. To check, we have 4 plus negative 1, that is equal to 3. Okay. A certain equation or a linear equation in two variables can be graphed in our Cartesian coordinate system. And the graph of the linear equation in two variables is a straight line. And the measure of how steep the line is called the slope of the line. And the slope of the line is being defined as a number that measures its steepness or how is the graph of as the linear equation in two variable is observed in the coordinate system. And there are different methods in finding the slope of the line, but the main formula is slope is equal to rise over run. We will use this formula in finding the slope if the given equation or linear equation in two variable is presented using the graph. Okay, so let's say this is the graph of the linear equation in two variables. As you can see, this is the Cartesian plane, this is the x-axis, this is the y-axis, and this is the graph of the linear equation in two variables. In finding the slope, you're going to locate 2 points in the graph. So this is the first point where the coordinates of 1, 1. This is the other point with coordinates of 5, -2. So in finding the slope, you're going to form a right invisible triangle, which is invisible from that point to this point. So you can also write here, to form a right invisible triangle here. And take note that we can also get another point aside from this. So we can use this point and this point. It depends on you. But take note that in getting 2 points, for it to be easier, you need to get a point that is exactly a whole number. Like this one, the coordinate is positive, whole number 1, 1. Same with this. So it is difficult for you to determine the values of this point because it is not a whole number. There is a fraction or decimal involved. Okay. So using the formula, slope is equal to rise over run. By the way, m is the symbol that represents the slope. We will start with rise. So we will select a certain point here, or we can also select this point. So we will start with this point and we will count the rise. When we say rise, this is the up or down of our triangle. So from this point, we have the rise, which is 1, 2, 3 units. Since this is down, if it's going down, it is negative. But if it is going up, it is positive. So we have 1, 2, 3. 3 units down, so this is -3, and then 1, 2, 3, 4. 4 units to the right, that is 4. Take note that in our run, if it is going to the left, this is negative. But if it is going to the right, that is positive. Same with the rise. Rise is going up, positive, going down, negative. In our run, going to the right, positive, going to the left is negative. Therefore, the slope of this line is -3, 4 or -3/4. Our next graph is the linear equation that is being represented by these blue lines. This is the y-axis, this is the x-axis. And then we're going to locate a certain point. We have this point and this point. Okay, so from this point, we're going to measure the up or down of our triangle. So we have 1, 2, 3, 4. So 4 units down, so that is -4. From here, 1, 2, 3, 4, 5, 6. So 6 units to the left, that is -6. Negative divided by negative will become positive, and 4 over 6 can be simplified as 2 over 3. Therefore, the slope of this line is 2/3. We can only use the formula and the example earlier if we're going to find the slope of the line using its graph. This time, we're going to find the slope of the line given any 2 points that will satisfy the given linear equation in 2 variables. And we will use the formula for slope m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. For example, in a certain linear equation in 2 variables, the point 3, 5 and 6, 2 is located on that graph. And in order to use this formula, we will represent these numbers as the x sub 1. This is the y sub 1. Same with this point. This will be the x sub 2. This is the y sub 2. We can also replace this 2 points. It can also be used as x sub 1, y sub 1, and this is x sub 2, y sub 2. This time, we will use these values for x sub 1, y sub 1, x sub 2, y sub 2. We will simply substitute these numbers to our formula. So y sub 2 is 2, so we will write 2 minus y sub 1 is 5, so we have 5 over our x sub 2 is 6, so we will substitute it by 6 minus x sub 1 is 3. Then solve. 2 minus 5, that is negative 3. 6 minus 3, that is 3. And negative 3 divided by 3 is negative 1. Therefore, the linear equation in 2 variables that is being represented by these 2 points has the slope of negative 1. Our next example is to find the slope of a line with the points negative 3, 0 to negative 6. Again, we will use the formula, and by substitution, y sub 2 is negative 6 minus y sub 1 is 0, x sub 2 is 2 minus x sub 1 is negative 3. Negative 6 minus 0 is negative 6. 2 minus negative 3 is 5. Therefore, the graph of the linear equation in 2 variables with the points negative 3, 0 and 2, negative 6 has the slope of negative 6 over 5.